For advent of code this year, I've been using Rust, and there's a really neat construct of the language that I want to talk about today, but we're not going to do it in Rust. We're going to port it to TypeScript. I'm talking about the option enum. The idea behind the option enum is that it's a wrapper for a value that may or may not exist. It should come as no surprise that we're going to model this in TypeScript as a union. And the union is going to be a union of none and some. And this is the terminology that Rust uses. I should say too that this is not unique to Rust. There are a lot of languages that do something like this. So the idea here is we're going to have this underscore type field to distinguish between the none and the some. And the main difference here is that if we have a sum, it has a particular value. And when you have an option of t, you could have nothing or you could have something. And so this can be really useful in cases where you may have a value or it might be undefined, or this function could return something, or maybe it throws an error, or this is a promise that returns a value or it might reject. And this option type can give you a unifying interface to interact with those different scenarios I just mentioned. Now we can create some helper values here for creating option objects. There's not really a need to construct new none values because it's just a hard-coded value. So this is the none that we can use. We have our none constant here, and it just is the object you would expect. Sum, on the other hand, is a function that takes an argument, and the return type is a sum of t. And we just return a new object that has our tag here, sum, and then the value as the argument. So now we have some easy ways to reference a none and to create a sum. Now, once you have a wrapper type like this, or an envelope, if you will, that we can put a value inside of, there's kind of two things you want to be able to do, right? The first one, of course, is we need to be able to create these. And the second thing, of course, is that we need to be able to consume them. Let's create a couple of functions that make it easy to create or put values into an option and also to consume or pull those values out of the option. So I mentioned earlier a couple of scenarios where you might have a value or you might not. And one of those is if you have some function that throws an error. Wouldn't it be great if instead of throwing an error, we could just get back a none instead? Sometimes we don't really care about that error. We just want to know, did I get my value back or not? So to do that, let's create a function here called optional catch. Now this optional catch takes a function that returns some type t. Optional catch will return you an option of t. And then of course in here we just have a try catch, and we call the function that gets passed in. And if that function returns the value of type t as we would expect, then we can create a sum and return that. If instead it throws an error, we'll just catch that error and we'll return none instead. So for example here, we could create a function called greet, and it's really simple to have this return hello name. But maybe let's say we don't want to greet anyone named Andrew. So we could say if name equals Andrew, then instead we'll throw an error. And so we either get our greeting or we don't. So what we could do now is create a variable here, and we'll call this maybe greeting, optional catch. Let's just say greet Andrew. And so if we look at the type of maybe greeting here, we can see that it is an option of string, which means there might be a string in here. And we'll look at how we can get that value out a bit later when we look at our consumes. But for now, we've successfully handled the error and we've captured our value. Now, another common scenario for possibly getting a value back is when you're using promises. So maybe we want to have an optional resolve function as well, so that we can wrap a promise result in an option. So this is our optional resolve here. It takes some promise of type t and it returns a promise of option of t. Now that might feel like we're going in the opposite direction because we now have more wrappers on our t value. But because we're taking a promise and we have to await it, there's no way we can return anything but a promise from this function. The nice thing though is that when we have something like our optional resolve here, we can know that when p might reject, promise of option of t is never going to reject. In the case of our catch here, we don't reject, instead we'll just resolve with a none instead. And so our code execution will continue until we actually need to inspect this value, but we don't get interrupted by an error. I've written this in a way that's pretty similar to what we did up here with our optional catch. Unfortunately, because of the way promises work, there's not really a way for us to combine these. I guess you could also choose to write this with then and catch instead. So we could do something like return p.then, and we get a value out of p, and then so we can return some of v. Otherwise, if we catch, we can just return none. So this is kind of a little bit more succinct. And if I comment this out, we can see that this also matches our types. This is maybe a little bit easier to read depending on the type of code you like to write. What we can do to actually give this a quick test is we can say maybe count optional resolve, and we can have promise.resolve of 34 in there. If we hover over maybe count, we can see that we get a promise of option of number back. Now, the other thing we could do here is more likely we would be doing this inside of some kind of async function like this, and I would probably have an await on here. And this and now is going to be an option of number. And so the await, of course, unwraps that promise for us. Now, handling an error that's thrown or a promise that's been rejected are two common cases, but you could also imagine wanting to create optionals around your own specific business logic. And for that, we can create what I'm going to call toOptional. This is a function that returns one of these option creating functions. So the way this works is toOptional has two generic arguments here, I and O, for input and output, right? And these are the types that we expect to receive and the type that we expect to put into the option. Now, the way this works is that we expect the output to be a subset of the input, and we can encode that by saying O extends I. Now, if you're not sure what I mean here, think about the scenario where maybe you have a value that could be null or undefined or a string, and you want an option of string. Or maybe you have something that could be a negative or a positive number, and you want it to be an option of a positive number. In this case, I might be all numbers and O might be only positive numbers. And so to determine that narrowing, we take some function here that takes an I and returns a Boolean. And if that is true, then we are saying here that I is O. So that means our value here, I, is of type O. And so then this returns a function that takes an argument of type I and returns an option of type O. And we could write this in a single line, as you can see here, what I've got commented out. We can just say if function of argument is true, then we have a sum, otherwise we have a none. However, why not include some try catch? I guess actually one way that we could make this a little bit smaller is I could put this in here in my try catch. May as well offer some free error handling while you're at it, but of course that's up to you. Now let's create an example usage of this, and let's go with one of those use cases I mentioned earlier where we want to filter out null or undefined values. So let's create something here we're going to call optional defined, and we need to call toOptional, and we know that we need to pass it some kind of function here. We want this to work for kind of any type, like, string or undefined, number undefined, that type of thing. So we're going to need some generic T here. And this is going to take an argument that is T or undefined or null. And then this function can return if arg is not equal to null. Now notice that this isn't type checking just yet. And for better or for worse, TypeScript needs us to include the return type here where we're going to say arg is T. And so basically what this means, if arg is not null or undefined, then arg is of type T. One case where I know we get undefined or null is when you pop something out of an array. So for example, let's create a quick array here with a couple of numbers in it, and we can grab a value out of that, right? If we do array.pop. Now, if I hover over B, you can see that it's either a number or undefined, which makes sense because when you pop, we don't really know how many values are left in the array. If we wrap this in optional defined, then what we should get back instead is an option of number. Okay, so we've looked at a couple of ways that we can create these option values, but now it's time to actually consume them. And the term that we use in Rust is to unwrap an option. Now, if you unwrap an option that is a none value, then we actually throw an error. So this is pretty straightforward to do in a basic unwrap. Here's an unwrap function that takes some option of T, and it's supposed to return a T. And if the type of option is sum, then we know that value exists. And so we can return option.value. Notice if I hover over option.value, the type is T, so it matches our return. And if not, we can throw some error. However, unwrapping and then just throwing an error if the value doesn't exist kind of negates, I think, all of the work that we did up here to wrap some value in an option. Because one of the main reasons I want to use a wrapper-like option is so I can gracefully handle the cases where the value doesn't exist. The basic unwrap feels a little bit too much like a hammer and not enough like a scalpel. So I like some of the variants on unwrap. One of the things you can do in Rust is unwrap or. And unwrap or takes a fallback, and we can try to unwrap this. And if we have a none, then we'll use the fallback instead. Now, the way I've implemented it here, we're using our first unwrap. We could instead do something like this, of course, right? Where we could say, if it's a sum, then return op.value, otherwise return the fallback. And this would kind of do the same thing. We don't need to depend on our other unwrap there. we could do it like this. But either way, however you choose to implement it, the effect is the same. We try to get a value out of option, and if it doesn't exist, then we use our fallback instead. Now there's one other way you can unwrap in Rust, and in Rust the function is called expect. I'm going to call it unwrap expect here, but the idea here is that you can pass in a message as the second argument instead, and we will still throw an error here. But instead of just throwing a generic can't unwrap error, what happens is you can actually choose what the error message is. So maybe this is a more valuable way to do this. Maybe you want to wait until you're closer to the edge of your program and then you can throw an error that has the right context. Maybe it has more context. It's kind of up to you, but this gives you the control to still crash your program in some way or let some other layer catch it, but you can choose exactly where to do that and what the message will be. So these are a couple of ways that we can unwrap an option. So let's bring this all together with a simple example. Let's say we want to write a function here, and we're going to call this get time difference. And so it's going to take an array of dates. Now it's going to return some number of milliseconds between two dates, and we expect this array to have two dates. We can say the start date is going to be array at 0, and the end date, of course, is going to be array at 1. Now we shouldn't just assume that both of these elements exist in the array. So let's wrap both of these in our optional defined wrapper. Now, if we have some kind of date range, we always need to have a start to that range. So start always has to be there. So let's pull out a start value here and let's use unwrap expect. And if there is no start, we'll just say range must have a start. And then I'm going to do value of. Now, notice that this function here, our unwrap, the expected return type is a date, so I can immediately start using date methods off the end of that. And basically, this is a really clean way to do a try catch, throw an error with our own custom message, and then move directly into the actual work that I'm trying to do. Now we need an end value, and I'm going to do unwrap or in this case, because maybe in this particular application, if there's no end date given to this range, then I'm okay with just choosing right now to be the end of the range. And we can do value of again to get the Unix timestamp there. And then finally, we can end this off by doing end value minus start value. I think this is a really elegant, very clean way to write code that handles values that may or may not exist. And we can easily and quickly handle different types of cases in very little code. We're abstracting away checking for a value and throwing an error if it doesn't exist, or finding a default value. Here in our getTimeDiff function, we can focus on the business logic itself. I've never actually used the option type like this in production TypeScript. I know that there are some TypeScript type utility libraries that have this type of thing, but like I said, I recently learned this pattern as I've been picking up some Rust, and it seemed really cool. I could definitely see myself using this in TypeScript in production in the future. Now, if you have used this type of wrapper or maybe similar concepts in TypeScript, I would love to hear about that in the comments, so do let me know. Otherwise, thanks so much for watching, and I'll see you later.